Welcome, everyone. I hope you're having a great week. This is a quick recording on parallel and perpendicular lines. Really, parallel lines and slope of parallel lines is a little bit of a review, and then looking at perpendicular lines slopes, which we haven't done yet. So our learning intention is the same. I'm learning about the connection between algebra properties of slope with the geometric properties of quadrilaterals, so I can understand the relationship between algebra and geometry. And the success criteria is I can use slope to determine if lines are parallel or perpendicular. I can use slope, distance, and properties of quadrilaterals to determine the identity of the shape. So as a quick review, we've been doing this a lot lately, and this is actually a slide that we've seen before. But finding slope, we have a choice between using the slope equation, the change in y over the change in x, or rise over run, which is just counting off the graph. And so on the left-hand side is an example of our equation method. To find the slope in any case, we need to choose 2 points on the line. They should be at an intersection to make it easier for ourselves, no estimating needed. And then if you're going to use the equation method, plug it into the equation. So the change in y over the change in x, you could see I have these 2 points labeled on the line. I plugged them in and I solved. The slope would be 2 over 1 or 2. For the rise over the run method, we just counted off of the graph. So I'm going to count how many spaces up and how many spaces over, or how many spaces rise and how many spaces run I need to get from one point that I identified to the other. So I'm just going to count. 1, 2, 3, 4 is my rise or my y value, and 1, 2 is my run or my x value, and slope is always y over x, so 4 over 2. And that can simplify to 2 over 1 or 2 as well. So we get the same slope either way with the equation or the rise over the run. I'm going to stick rise over run for this recording because it's the quicker way to count off the graph. If anyone has any, one moment. If anyone has any questions about the equation method, you could let me know. All right, so this next slide here shows parallel versus perpendicular lines. As a reminder and review, on the left-hand side, parallel lines are lines that do not touch. They always have the same distance apart forever. And if the slopes of two lines are equal, then they are parallel. So the slopes of parallel lines are equal. On the right-hand side, we have an example of perpendicular lines. They are lines that cross at a 90-degree angle or a right angle. This one's the new piece. So the slopes of perpendicular lines are negative reciprocals of each other. So we're going to go over that and what a negative reciprocal is. So as a quick review, this is finding slope to see if they are parallel lines. And remember, again, if lines are parallel, they have equal slope. So let's see, I'll highlight as we're going through. So I'm going to find the slope of RQ, which is across the top. Let's make that red and a little bit bigger. And then also get the slope across the bottom. So SP, and we want to see if they're equal. If they're equal slopes, then those are two parallel lines. So I'm just going to count off of the graph. So again, rise over run, I'm going to go from one vertex to the other, just because that's easier than having to choose a line in between and making sure that it's on a vertex. So I'm going to count up 1, 2, 3, 4, 5, and then I'm going to count over 1, 2. Let me do that again. I'm not sure if I started in the right place. You know what's the better way is to draw some lines. I'm going to go ahead and start from R and go over to Q this time. 1, 2, 3, 4, 5 in the Y direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 5 over 15 for the slope of RQ, which simplifies to 1/3. And actually negative, I should have put negative there because it's a negative slope. It's pointing downwards. And now I'm going to do SP at the bottom. So 1, 2, 3, 4, 5. Oh, I'm sorry, I think I went too far. 4 in the Y direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 over 12. And again, negative because that line is pointing downwards. And that simplifies to negative 1 over 3 as well. So those two red highlighted lines are parallel because their slopes are the same. So we're going to check the other two lines now. Right. Maybe I'll just get the other, instead of making new colors, I'll just move these around. So we're going to do RS and PQ. So we want to know if opposite sides are parallel here. So now we're going to do kind of the left and right, and again count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 1, 2, 3, 4. So 14 over 4 for RS, which doesn't really simplify easily, so I'm going to leave it alone. This is positive, a positive slope, and we'll do the other one. So 1, 2, 3, 4, 5, 6 in the X direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 in the Y direction. So we have 13 over 6, which also does not simplify easily, and those two are not equal to each other, so those lines are not parallel. So we have one set of parallel lines in this image, and again, that should be review. We've done that before. There's slides posted in the course if you need some more work with that, and also in IXL. So let's take a look at perpendicular lines in this next example. So I want to go ahead and see if all of those angles here in this shape have 90 degrees, or basically eventually look to see if that's a rectangle, right? So rectangles, squares, they all have 90-degree angles. So we can figure out if the 90-degree angle is there if the slopes of the two lines that make up the angle are 90 degrees. So I'm going to find the slope of each of those sides of this shape and take a look and see if any of them are equal or parallel. Or I'm sorry, equal and parallel, or perpendicular and negative reciprocals of each other, I should say. I'm going to move these over a little bit so there's some more space. Okay, so we're going to do the slope of each side. I'm going to do JK. Oh, that's not JK. Let's do AB, BC, CD, and DA. Okay, so I'm going to start with AB and just count. So I have 1, 2, 3 in the X direction and 1 in the Y direction. So that's going to be 1 over 3, and that is a negative slope because the line is pointing down. Next, I'm going to look at BC. So I'm going to count that one. I have 1, 2, 3, 4, 5, 6 over 2. So I have 6 over 2, which simplifies to 3 over 1. And that is a positive slope because BC is pointing upwards. So let's stop there and just focus then on negative 1/3 and 3 over 1. I know that those two lines are perpendicular to each other, and that is a 90-degree angle. because these two slopes are negative reciprocals of each other. So down here at the bottom, I'm going to just do just a made up example. Let's say I have a fraction or a slope that's 3/4. The reciprocal of 3/4 is 4/3. So when you take the reciprocal of a fraction, you flip it around. So that's the reciprocal. Perpendicular line slopes have negative reciprocals of each other. So if I have 3/4 that's positive, then I'm going to put a negative in front of the reciprocal. So these two slopes down here at the bottom would be negative reciprocals of each other and therefore perpendicular lines. So that's where we're headed as an, again, example at the bottom. So let's back out of that and look at what we have. So these two slopes are also negative reciprocals of each other. So we have 1/3. The reciprocal of that is 3/1. One of them's negative, the other one's positive. So again, those two are negative reciprocals of each other, and therefore those two lines are perpendicular and form a 90-degree angle. I'm going to keep going and look at the slope of CD. So across the bottom, I have 1, 2, 3, and 1. So again, 1/3, and that is negative. And the last one, DA, I have 1, 2, 3, 4, 5, 6/2. And that one, I lost my pointer for a moment there. There we go. So 6/2, which is positive, and simplifies again to 3/1. And so all of these slopes are going to be negative reciprocals of each other, sort of say. So what this is telling me is that that is a rectangle in the sense that all four of those angles are 90 degrees. So perpendicular lines are negative, or perpendicular line slopes are negative reciprocals of each other. And if you can identify that in the graph, then you know you have a 90-degree angle. Okay, so let's look at this is an example doing the same thing, just adding in the distance. And instead of just saying, hey, is this a 90-degree angle? Look at the slopes. The question this time is this a rectangle? So we need to know the properties of a rectangle. It's grouped in with the parallelograms in the sense that opposite sides should be parallel, opposite sides should be equal, all of those angles should be 90 degrees, and so forth. And so if I wanted to prove that this is a rectangle, I need to prove that all of two sets of opposite sides are equal. So I've used the distance formula at the top to try to show that. And then I have to look at the slopes, make sure that opposite sides are parallel, so equal slopes, and then consecutive sides are perpendicular, so negative reciprocals of each other. So up here at the top, I found the distance of MN and PO. So kind of like the top and the bottom. And already I found that they are not equal. So I know that this isn't a rectangle. But since we're focusing on slope, I wanted to keep going. So if I wanted to prove that opposite sides are parallel, again, I need to show that the slopes are equal. So this is MN and PO, so top and bottom. I've counted out those slopes, and they are equal. And therefore, those two sets of sides are parallel to each other. But we can't stop there, especially if we started with slope. We have to make sure the other two opposite sides are parallel. And if you count the slope there, they are not. So again, not a rectangle. If you go down and see if you have perpendicular lines, again, you don't have to do all of three of these. If you prove one that's not working, then it's not a rectangle. But just to show the example of each piece, I went on and did the perpendicular lines. Again, MN and MP. So this kind of side right here and here, I wanted to see if that's a 90-degree angle. And if you look, it is, because those are negative reciprocals of each other, those slopes. I checked PO, so again, that worked. So far we had 3 right angles, but then that last slope on that last slide was not a negative reciprocal of the others, and therefore, again, not a rectangle. So showing you an example of all of the things that you would have to check. You could strategize again, decide where you want to start. Should you start with slope? Is that quicker and more comfortable for you? Would you rather the distance formula? Is that quicker, more comfortable for you? Would you rather compare the slopes for parallel lines or perpendicular lines first? Again, you could choose where to start, and depending on your answers is going to determine how far you have to keep going. And so there is a quiz that I have currently open, if you're listening to this, that asks some questions along these lines. So I wanted to do one more example in the recording that's going to ask a question similar to what you're going to see when you go in to take the quiz, and also straight out of IXL. And so the question here, the picture, we could see that we have a quadrilateral QRST. And I want to know, is this a square? So in order for this to be a square, all 4 sides have to be equal, opposite sides parallel, all 4 angles have to be 90 degrees, and so forth. And so I have multiple choice this time. And so again, I could start wherever I want to, but maybe I'll start with one of those multiple choice options that's going to be the easiest for me to do personally, or the one that I'm more comfortable with. And so I would probably start with this one at the bottom, where we're trying to see if we have perpendicular lines, only because for me personally, I think it's quicker to count the slope off of the graph than to set up the distance equations and figure that out. But again, it's completely up to you. Since we have answer choices here, I don't want to go and try to see if SR and ST are perpendicular to each other, because that's not going to help me eliminate one of these choices, right? So we only need to do what's here as a multiple choice option so we can eliminate the choice. So I'm going to look for QR and RS first. So QR is on the right-hand side and RS is across the bottom. So I want to know if that is a 90-degree angle. So I'm going to go ahead and count the slope. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the y direction. 1, 2, 3, 4. So I have 10 over 4 for QR. I'm just going to write it here, right underneath QR. And that's positive. And then I'm going to check RS. So again, count the slope. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 4 over 10 this time, and this time negative because it's pointing down. And so, yes, those are perpendicular lines. Their slopes are negative reciprocals of each other. So not this one, because this one says they're not, and I just showed that they are. And so now I have a choice between the rest of them, and it looks like all the rest are distance formula questions. So are all the sides congruent? Are these 2 sides just congruent, or are these 2 sides not congruent, and so forth? So it's up to you where you want to start. Notice across the bottom, I did 3 distance equations instead of 4. There's 4 sides, but the question options do not ask me about that 4th side. So I have QR, the right side. I have RS across the bottom. I have ST on the left, but I don't see QT anywhere in these options. So I did not even go to that distance formula. I'm going to start with the other 3. And then if I have to go to that 4th one to prove up here that yes, all the sides are congruent, then I'll go ahead and do that. But I'm not going to start there because that's not one of the choices. Again, you can, it's just saving me some time. And so you can see as I went across the bottom, I found that QR and RS are congruent to each other. But then when I did that 3rd side, I found that ST was not. So this is not a square. So if I go back through my answer choices, then this one says, yes, all sides are congruent. Nope, I just found that they're not. The next one says QR and RS are not congruent, but they are. QR and RS are congruent, so not that one. The third option says RS and ST are not congruent. That one's true, right? RS is 10.7, ST is 11.1. They're different, so not congruent, and that's going to be our answer. So when you get to the quiz, your questions are going to look similar to this one. And again, they come right out of IXL that's already clicked on for you. So if you'd rather go over there and practice first, you can. And I believe I have the due dates as Friday. However, I have it open through the end of next week. So if you're not sure and you want to ask questions or go over it in class on Monday when we get back together, we could do that. So the assignment for Thursday and Friday of this week, so that's April 25th and 26th, is to watch this recording and then try that quiz in the course if you're feeling comfortable with it. It's set up to take 3 times, so you could try it the first time around and see how it goes, and then wait for the second and third try if you want to for the following week. Right? If you have any questions, again, let me know. Otherwise, I will see you on Monday.